This is a very good question, which brings us back to the basic theory which we have learned. So the question is, the activities are given, predecessing activities are given, estimated duration is also given. Suppose for all activities other than S, take the estimated amount of time, then what is the maximum duration of the activity S without delaying the completion of project? So the project should not be delayed. So then if that is the case, and if the all the activities which is given, if that is the exact means the we have to take that estimated amount as the means the as a fixed thing, then how can we what can be S maximum? What is the maximum duration with which S has to be completed without any delay in the project, right? Now we go back to the theory. So we were talking about earliest start time, earliest finish time, latest start time, and latest finish time, and duration, right? That is how you calculate the slack and float, and how to means the critical path and all the things are calculated. But in that thing, there was an assumption that our duration is fixed, right? When I means in the theory, we have taken an example for the latest start time and latest finish time, or to compute the slack. So the activity duration is 4. The earliest start time for that activity is the 5th week. The latest finish time of that activity is 12th week, right? So by 12th I have to complete that activity, and I can start my activity only at the 5th week. My project means the duration of that activity is 4 weeks. So we were telling that, okay, if I start in the 5th week, I can complete in the 9th week. If I start in the 6th week, I can complete the that activity in the 10th week, right? And maximum we can start is maximum delayed time means the latest start time will be 8, because I have my latest finish time is 12. So in all that thing, so we have an assumption that our duration is fixed. That 4 is the duration. So that is fixed, and we are playing with the starting time and finishing time. But if you think, suppose if I'm saying that my earliest start time is 5 and latest finish time is 12. So we can also make that thing like I can do that activity within 7 days. Only I have to complete that activity within 7 days. I'm starting at 5th week. I am ending at 12th week. So I'm slowing down the process. So sometimes that also has to be done for the completion for the projects. Certain activity we cannot we can delay the process, not the starting or finishing time. So we are delaying the process. So this is a question such like that only. So let's see how. So it is asking what is the latest what is the maximum time of S for the maximum duration of S without delaying the project. Suppose for that also we have to anyhow construct the network. So let's draw it. So P and Q does not have any predecessor. So directly I will start with this is my P with duration 5, Q with duration 1. Now Q has a R as predecessor. So this is my R with 2. Now it is saying that P and R has to be completed for S. So I will start S from here, and I will give a dummy activity from here so that I can give the precedence relationship. So this is my S with the duration 4. Now T is starting with 3, and U is from the merging event S and T. So S and T can be merged together to form, and it is starting from P. So this could be my T with duration 6, and I can finish with my this U with duration 3. So this is basically the network. Now let me calculate the critical path also. So I will explain why P. T U P S U and Q R S U. So 3 parts are there. So 5 plus 6 plus 3, 11 plus 3, 14. P S U 5 plus 4 plus 3, 9 plus 3, 12. Now Q 1 plus 2, 3 plus 4, 7 plus 3, 10. Now this is the critical path and this is the length of the critical path. Okay. Now what is that critical path? T P T. So this is my critical path with the double line. Now it is saying that all these things are fixed. Okay. For P, other things are means estimated amount of time is given, and we are taking that as a consideration. But S has a fixed flexibility. So what is the maximum? Now it is 4. So how much maximum it could be? So our project completion time should not be delayed. So what is the maximum? Means so this is this activity is there. This is there. So if I from this we can see that means since this is the path without S, so maximum we can increase if I'm counting this will be 10. So 14 minus 10 will be 4. 4 I can increase, but if I increase S by 4 weeks, so that S will be 8 weeks, then what will happen? This will go higher, right? So how much is will be 4? It will be 16. So our project completion time is changed. So what we can do is maximum is we can increase 2, right? Suppose if I increase S by 2, so S is now 6, then what will happen? So this means this and this path will be PSU will be the critical path. Then still the project completion time will be 14 because both this both this will become the critical path. So maximum time we can give to maximum duration with which S has to be completed is 6. Now it is 4. If you are not changing other activities, that's what it is given. Take the estimated amount of time for all other activities except S. Then what is the flexibility of S is maximum it can go is up to 6. So so 6 is the answer. So this is how you can compute the things. So this is a concept where means the concept has to be clear. So now you are not changing means now you are playing with the duration rather than the changing the earliest start or latest finish or something like that. Okay, so that's how you can. So since there is only 2 is the difference between these 2 paths we are having S, then that is the maximum time you can allow along means plus the already having duration. So 4 plus 2 will give you 6. So that is how you get the solution. This is also a tricky question. It is testing you how means it's about how you draw the network. If you can draw the network, the critical path finding critical path is very simple, right? But our means this thing is slightly different. So they are given a relation. So x less than y and z means that x is the predecessor of y and z. So this is the meaning. So that is how the precedence relationship is given. Okay. So what does it mean? A less than B, C, D means A is the predecessor of B, C, and D. Similarly, B is the predecessor of E, F, and G. Such like the other things are given. Now it is slightly different because we were the A less than this means B, C, D, and B, C, D are the successor of A. So this now we have learned some stereotype kind of problems saying that this is the predecessor, this is the predecessor of that one. But this is given in the other direction. Successor activities are given along with the activity. So we need to construct the network. That's only. It's not so difficult. but don't get panic when you see these kind of symbols or if it is giving in a different way. So try to understand the thing and use your knowledge to explore those things. Okay, so let me draw the network. So this means A. So A is a bursting event. So let me draw A, and from A, B, C, D, B, C, and D is starting, right? So let me write. Let me put C here. B. Maybe I will change. I can change it later. I mean, sometimes if you are doubt about certain things, you can start drawing, but you can change it anyhow later. Now, what is it saying? B has three bursting events: E, F, and G. Now you know that I is the successor activity of H, G, F, and C. C also I, and I is the last event. Okay, and here D is G is followed by D, H is followed by E. Okay, so there are three events. I will put that E. So this is E, and E, F, F. Let me draw F here. E, F, and G, G, and E, F, and G, and G is the and D is also B is also okay. G is also starting from B. B and G is a okay. Then what we can do is we have the relationship that G is presiding with D and also presiding with V, right? So I can put G here with a dummy activity and giving the precedence relationship, so that I can understand that okay, G is presiding with B and V. Now we know that G, F, H, and C are all merging together to form I. Now, now I have to change this thing. So, so F will reach till I. So let me draw that thing first. Then this will be starting node of I. Then G. This has to be go there. This has to go here, and one has to be a dummy activity has to come here, or I can join it there also, and also from I also I have to come here. Then to form I. So this is I. Now let me remove those things. G also. This is a dummy activity, and this is also fine. No, so you can make slight modification. It need not be straight lines. It's just for your understanding. Actually, for actual cases, it needs to be straight lines. But since you are doing it and nobody is looking at your answer sheet, it's okay. Now this is the network. Okay. Now give the time for each. A is 5. Here this is also not there. I will erase it, or you can consider this as a dummy activity. Now we can so C is 10, B is 7, D 6, G 7, F 9, E, this is E. E is 3. All the things I is 2. H, where is H? Okay, this is not a dummy activity. This is H. H is from E, right? Yeah. Here it is. So this is H. This is not a dummy activity. This is H, and H has the value 4 and I 2. So that's how we complete the network. Now let's just list down the path and find out. A, CI, A, B, E, H, I, A, B, G, I, A, B, F, I, A, D, G, I. What are the values? ACI 10 plus 5 plus 2, 17. AB means 12. E 15 plus 4, 19 plus 2, 21. ABG 12 plus 7, 19 plus 2, 19 plus 2, 21. ABF 9, 12 plus 9, 21 plus 2, 23. ADGI, 11, 18, 20. So maximum is 23. This is our critical path. So the answer will be C, 23. So just to understand only the tricky part is how will you interpret the data? How will you understand the data? It will be slightly confusing in the first go. You may miss certain things, or your network will become seems to be very complex. But once you drew it a rough sketch, then you can easily find out what are the preceding activities and how to complete the network. Then once you get the network, it is very simple. This question is from PERT, which is asked in 2019. Basically, what we have to find out what is the variance of the critical path. So for that, we have to draw the network and find out the critical path. So for drawing the network, we need to find out what are the TE values. TE is used for, then the estimated time will be used for this one. So it is nothing but optimistic time plus TE will be TO plus TP plus 4 times TM divided by 6. So let's find out this one. So 4 16 plus 6, 22 plus 2, 24 by 6 will be 3. 4, 5, 10, 20, 20 plus 12, 20, 32, 32 plus 4, 36 by 6, so 6, 8, 4, 24 plus 5, 29 plus 1, 30 plus 8 times 4, 32, 32 plus 10, 32 plus 11, 41, 41, no, 43, 43 plus 5, 46 by 6, 8, 20, 20 plus 10, 30, 30 by 6, 5, 6, 24 plus 4, 28 plus 10, 38 plus 4, 42, so 7. Now we have this one. So let's draw the network. 1 to 2, 2 to 3. Oh, this one 3, 2 to 4, 4 to 5, 3 to 5, and 4 to 5. So a box kind of network. This is 5. And duration 1 to 2, this is 3, 2 to 3, it is 6, 2 to 4, it is 8, 4 to 5, 4 to 5 is 7. 3 to 5 is 5. So only two parts. 1, 2, 3, 5. 1, 2, 4, 5. So 9 plus 5, 14, or 8, 10 plus 18. 18, right? So among this one, 18 is the highest, and this is the critical path. So this 1, 1 to 2, 2 to 4, 4 to 7. This is the critical path. So we need to find out the slack. So for slack, we need to find out variance. So variance is nothing but is the square of TP minus TO divided by 6. All square will give you the variance. So how it will be? We need to find only for this thing. So 1 to 2, 6 minus 2, which is 4. 4 by 6, which is equal to 2 by 3. So 4, which square means 4 by 9. Now 2 to 4, 2 to 4, this one. 11 minus 5, which will be 6. 6 by 6, this is 1. 1 square is 1. Now it is 4 to 5. 4 to 5 means 14. 14 minus 4, 10. 10 by 6 means 5 by 9, 5 by 3, and 25 by 9. So variance of the critical path will be 4 by 9 plus 1 plus 25 by 9, which will give you 9 plus 4, 13, 38. 38 by 9, which will be equal to 4, 20, 20 by 2, 18, again 2, 20, 2, so 4.22. So it is up to 2 decimal places it is asking. So 4.22 will be the answer. So very straightforward question. So we can get 2 marks.